Hello and welcome back once again to this video tutorial. This will be the second video for standard deviation, and we are going to solve question number 6 from the textbook. Okay, practical question number 6. So in the question number 6, the series that is given in the question, it is discrete series, and we'll be solving this sum using by a direct method. Okay, so let's write it down on top of it. Direct method. So the previous sum that we did, question number 13, was also direct method. However, that was individual series, so therefore the formula will be different than the previous one that we have discussed. Now let us first find out the value of mean, because in all the series you will be needing to find out the value of mean. Now I have already calculated the value of fx and also the sum of fx. So the reason why we do this is to find out the value of mean. So I have the sum of fx and also the sum of the frequency, that is the value of n. So let's find out the mean. Clear? Okay. So mean is equal to sigma fx by n. So this is the formula to find out mean in discrete series. So here the sum of fx is 3783.5 divided by the sum of the frequency is 270. So if you divide this one, you will get 14.013. Okay, so therefore if you want to use 2 decimal, it's up to you. If you want to use 3 decimal also, it's up to you. Clear? So now let's find out the value of dx. Now to find out value of dx, we will be needing x minus mean, right? So we have the value of x here, we have the value of mean here. So if you subtract x minus mean, that is 12 minus 14.01. I'm taking 2 decimal here, okay? 01. So 12 minus 14.01, you will be getting minus 2.01. Okay, here as well, minus 1.51. I'm subtracting, use this formula. Okay, use this, x minus mean. This is x, this is mean value. So I'm subtracting all these numbers from here. So 13 minus 14.1, it is minus 1.01. Next, 13.5 minus 0.51. Next, 14 minus 0.01. Next, 0.49, 0.99, 1.49, and lastly 1.99. So now you have to square this value, dx squared. Okay, so now square this value. So if you square minus 2.01, you will get 4.0401. Next, 2.2801, 1.0201, 0.2601, 0.0001, wait a second, 0.0001, next 0.2401, 0.9801, 2.2201, 3.9601. So this is what if you square up the value of dx, you will get all this value. Now what we have to do next, we have to find f dx square, that is f into dx square. Okay, so you have the value of f here, 5. 5 into 4.0401 will give you 20.2005. Next again, 20 into 2.2801, you will get 45.602. Next, 30.603. Next, 11.1843. Next 0.006. Next 13.4456. Next 36.2637. Next 35.5216. And lastly 11.8803. Alright, so let me just, okay, let me rewrite this once again. Alright, it is 35.5216 plus 11.8803. Now you have all the value of f dx square. Now you can add up all this value and find the sum of sigma f dx square. Okay, so let's write it down here. F dx square. If you add up all this, you should get 204.707. That's 204.707. So this is our value. Now let's go back to the formula to find out the value of standard deviation. Now standard deviation, the formula is square root sigma f dx square minus by n. Now we have the value of sigma f dx square, and that is 204.707. Let's write down here 204.707 by our n is 270. So if you divide this one and find a square root, you will be getting 0.8707. So this is our standard deviation. Okay, and question number 6, you are asked to just find out the standard deviation and nothing else. So therefore we will not be finding the coefficient here. Clear? So yeah, with this we are done with question number 6. So we'll be solving one more sum from question number 9, and that we will be solving in step deviation method. Okay, so let's proceed to next question. We're done with question number 6. Now please don't copy whatever figure that you see here. You just watch properly first and then do it by yourself. Clear? And if you need any help, you can also refer examples from your textbook, or you can watch this tutorial anytime. Now let's go back, let's go forward and solve another sum, that is question number 9. Alright, question number 9. Even in question number 9 here, I've actually made a table here for shortcut method. So let's solve this in shortcut method, okay? Not in step deviation. First, let's solve this in shortcut method, and then thereafter, if time permits, we will try to solve in step deviation as well. Let's just write down here shortcut method. Shortcut or assume mean method. Assumed mean method. Okay. Alright, so here as well we have to find out mean, and that's the reason why I have already calculated the value of fx here. And in here our x is our midpoint. Okay, don't get confused because this is continuous series, so therefore we have to find out midpoint. So I hope by now you are aware of how to find out midpoint. 5, that is 10 plus 0, 10 by 2, 5, 20 plus 10, 30 by 2, 15. So upper limit plus lower limit divided by 2 will give you the mid value. Okay, so now if you add up all the sigma fx, let's see how much we'll get. Okay, so if you add up all the fx value, or you can write fm, no problem, you'll be getting 4500. Okay, so let's underline this one. let's just write down here 4500. This is our value. So let's find out mean here first. Mean is equal to sigma fm by n. Now here, don't get confused. You want to write fx or fm, it's up to you. You can either write fx or you can write fm because this is midpoint, right? So fm is 4500 by n, sum of the n value, and here is 100, I believe, yeah. So if you add up all this, you will get 100. So by 100, it is equal to 45. Now this 45 is our mean value. Now what we do is, let's find out the dx value. Okay, now forget about the mean here. Now we will be using this mean later on because we're also asked to find out the coefficient of variation. So for coefficient of variation, we'll be needing mean, and that's why we calculate mean in the beginning. Now let's start solving our sums. Since we are going to do it assume mean method, so we have to assume one mean. So let's assume our mean. We have to assume mean from the midpoint. Okay, 1 2 3 4, 1 2 3 4. So let's take 45 as our assume mean. Clear? So to find out assume mean, what we have to do is x minus a. What is x here? Midpoint. What is a here? 45. So we can also write down here assumed mean is equal to 45. Our actual mean is also 45. Our assumed mean is also 45. Okay. Now to find out dx, x minus a, that is 5 minus 45. So it will be minus 40, minus 30, minus 20, minus 10, 0, 10, 20, and 30. That is what we are going to write here. Yeah. So now we have to square this value here, and that way, if we square it, our minus sign will be omitted. So 4 is 16, so therefore we can write 1600. 3 is 9, 900. 2 is 4, 400. 10, 100. 0, 100. 400. 900. So this is our value. So now we also have to find out f dx square. So that is f into dx square, right? So we have missed out one more line here. Just a second. Let me just draw one more line. Our table is very colorful, but it's okay. Alright. So, okay. Let's first find out f dx. Now, if we have to find out f dx, that is f into dx, right? So f 4 is 20. So minus 200. Okay? 15 into 3, sorry, 8 into 3, 8, 3, 24, minus 240. 7 into 2, 14, minus 140. 12 into 10, minus 120. 0. 20 into 10, 200. 10 into 20, yeah? 10 into 20, 200. 10 into 30, 300. Now, let's find out our f dx. F dx square, that is f into dx square. So if you multiply 5 into 1600, so you will be getting 8000. Okay, similarly 8 into 900, you will get 7200. 7 into 400, 2800. 12 into 100, 1200. 28 into 0, 0. 20 into 100, 2000. 10 into 400, 4000. 10 into 900, 9000. So we have to find out the sum of this one, sum of this one as well. So if you add up all this value, then you should get 3. So let's first write down like this. Sigma f dx square is equal to 34200. So if you plus all this, you will get 34200. Okay, so now let's plus this one. 3, 4, 5, 6, 7, 700. So if you add up 300, 200, 200, you'll get 700. Now 200, 200, 400, 500, 600, 680, 700. So minus 700, minus 700 and plus 700, it is 0. So our value for sigma f dx is equal to 0. Okay. Now we have all this value. Let's put this value in the formula to find out the standard deviation. Our standard deviation formula is sigma f dx square by n minus sigma f dx by n whole square. Okay, so f dx square by n whole square. Now what we have to do here, we know the value of this one, right? It is here 34200. So let's write down here 34200. Our n value is 100 minus, it is 0 by 100 whole square. So this is 0, and if you do this one, you will get 342. 342 minus 0 is 0, right? So if you find out the square of 342, you will get 18.49. So this is our standard deviation. Okay. Now we are also asked to find out the coefficient of variation. So let's find the coefficient of variation here. So coefficient of variation is equal to the standard deviation divided by mean. Our standard deviation is 18.49. Our mean value is also 45. So if you divide 18.49, so if you divide 18.49, you will get 0.4109 into 100. So if you multiply with 100, you should be getting 41.09%. So our coefficient of variation is 41.09%. Okay. So with this, question number 9 is over.